So, hello everyone, welcome to Concepts in Chemistry YouTube channel, and also welcome to the Chemistry Concept Booster series. So, in this series, we usually discuss lots of different conceptual questions from all branches of chemistry. So, we already discussed 20 questions in this series. So, among those 20 questions, 10 are from organic chemistry. Now, today in this video, we will be discussing more 6 questions from organic chemistry. So let's discuss. So chemistry concept booster 21. So in chemistry concept booster series, this is the 20 on number questions, and this is the 11 questions from organic chemistry, because we already have discussed 10 questions from organic chemistry in this series. So normally in chemistry concept booster series हम लोग different type of questions from organic chemistry, from physical, inorganic chemistry discuss करेंगे. Normally जो questions competitive exam में पूछते हैं means GATE, NET, Barc, Iit-Jam or any other MSc entrance examinations. So we maintain the quality of questions, means जिस तरह का questions normally एग्जाम में सिलेक्ट होता है, हम लोग ऐसा ही क्वेश्चंस प्रिपेयर किया बट थोड़ा डिफरेंट टाइप. सो एज अ रिजल्ट क्या मिलेगा? सो वी विल डिस्कस लॉट्स ऑफ क्वेश्चंस फ्रॉम डिफरेंट टॉपिक्स ऑफ केमिस्ट्री. सो डिफरेंट टाइप ऑफ क्वेश्चंस सॉल्व भी हो जाएगा. बाय सॉल्विंग दिस टाइप ऑफ क्वेश्चंस मैक्सिमम टॉपिक रिविजन भी हो जाएगा. सो आई थिंक for particularly for organic chemistry, so we have to practice lots of different type of questions. So if we practice, then in competitive exam, so हम लोगों को थोड़ा confident मिलेगा ये mechanism draw करना और perfectly use of reagents. So that's why we started in this series, the series chemistry concept booster. So in our upcoming videos we will see lots of different type of questions, and that will help you a lot for your improving your power in question solving, and also to improve your concepts. So regarding all topic in chemistry, so let's discuss the first questions in this video. So question number 11 from organic chemistry. So this starting material, this is a alpha beta gamma hydroxy carbonyl compound is given, and the reagent is sodium borohydride, second reagent methyl chloride triethylamine, and third one is ammonia. So let's discuss the mechanism, then we will see the options. कुछ कुछ केस में ऐसा होता है जो 2 और 3 और नॉर्मली 2 पॉसिबल प्रोडक्ट हम लोगों को मिलता है by the mechanism, but among these 2 products the maximum stable on will be the major product, or the product that will form major in amount. So formation of this product is faster, or we can say feasible. On formation of one product is more feasible, then that will be the major product. So in that case, by seeing the options, either options is there for 2 products or only one product is given. If 2 products is given, then we have to find the major product, more stable product, or the formation of the product is more feasible. That will be the correct options. But first we have to see the starting material carefully, then we have to treat the each reagents carefully, then we will see the options. Let's discuss the mechanism. So this is the compound So sodium borohydride, we all know that sodium borohydride reduces carbonyl compound to alcohol. So in this case, the reduction is stereospecific, means in this case, if we consider this is a plane, 5-member ring along with this carbonyl is one plane, then in the below of the plane CH2 OH group is there. So this question is from a publication, so this is just a part of a total synthesis of a molecule synthesized by Ije Core group. So in the tetrahedral letter they mention that boron and oxygen, there is some interaction take place between boron and oxygen. That's why hydride transfer takes place from back side, means below of this plane. So hydride should be below and accordingly OH should be above of the plane. So in this paper they mention that so some interaction between boron and oxygen take place, that's why this OH group guide the hydride attack in this case. So now there are two OH group in this product, one is secondary one, this is primary one. If we use methyl chloride, we all know if there is alcohol, we used methyl chloride to protect the alcohol. Since in this case no equivalence is mentioned, excess or two or only one equivalent, we have to assume that there is lot of methyl chloride, means in this case both the OH group will protect, both the OH group will transform to OMS. So now in this step ammonia is present, so ammonia will attack this primary carbon to release the OMS. So normally we all know that SN2 substitution, so primary carbon is more prone towards SN2 substitutions, secondary carbon is somewhat take part in SN2, but tertiary carbon means 3D carbon will not take part at all in SN2 substitution reactions. So in this step, see, ammonia will attack only this carbon to release this OMS. So now it will transfer CH to NH2. In this step, in this carbon no substitution take place at all, but once this compound is formed, we can write this compound as in this manner. In this compound, see, still this is a secondary carbon, and we all know secondary carbon is somewhat prone towards SN2 substitutions, but in this case two driving force. One is in the molecule itself a nucleophile is present. In this case these reactions take place at via intermolecular fashions. Now in this compound one nucleophile is present within this molecule, so the intramolecular substitutions will favor in this molecule. That's why still it is a 2-degree carbon, still this NH2 group attack this carbon to form a 2 5-member bicyclic compound, 2 5-member bicyclic compound. So formation of a 5-member ring is the driving force, and also since in this case in this compound the nucleophile is present within the molecule itself, that's why the nucleophilic substitution occur in this secondary carbon. So in this case substitution occur via intermolecular fashion, in this case it is intramolecular. So we will get this product. Now we can draw this product like this. If this we can write above the plane, then this should be same in the plane. So this will be the product for these reactions. One point you have to keep in mind that in this case only one substitution take place, that is primary carbon. Secondly, since intramolecular nucleophile is present in the molecule, that's why SN2 substitution take place in this secondary carbon. In this case only primary carbon will take parts in SN2 substitutions. In this case the secondary carbon also take part in SN2 substitutions. This is via intermolecular, this is via intramolecular. So at last we obtain this kind of product. So 2 5-member ring, see the options. So from option C and D, 2 5-member ring is there. On that, isopropyl group should be below the plane and methyl group should be above the plane. So see this product will perfectly match with the option C. So option C is correct options for these questions or these reactions. Let's move to the next questions. So in these questions, this alpha halocarbonyl, we can say alpha halocarbonyl, but in this case in beta positions, on halogen is means bromide, bromide is present. So we all know that if there is presence of alpha halocarbonyl compound and we are using a base like sodium ethoxide, then there is a chance of Favorsky rearrangement. So I just mentioned a few minutes ago, by solving this kind of reactions, we will cover, I am telling you that 80% or more than 80% we will cover all the topics in organic chemistry. That is name reactions, use of reagents, different type of topics from organic chemistry we will cover by solving this type of questions. So yeah, we will practice lots of questions, and by practicing this type of questions, I cannot say 100%, but 85%. I am guaranteeing you that you will be able to solve different kind of questions in competitive exam. अगर questions common नहीं आया तब भी आप लोग solve कर सकोगे if you practice lots of questions, lots of different type of questions from organic chemistry. So let's discuss these questions. So alpha halocarbonyl compound is there, we are using base, so there is chance for Favorsky rearrangement. Then we will see later what will be the mechanism after formation of the Favorsky product. See, this is the reactant given. Carbonyl group is there. In alpha carbon, on carbon no hydrogen is there. In this alpha carbon 2 hydrogen is there. So sodium ethoxide mean base will abstract this alpha hydrogen. Alpha hydrogen of any carbonyl compound is acidic, so it will abstract this hydrogen. Now if we draw the enolate anion of this compound, then it will be like that. Now this will attack, this negative charge will attack this carbon to release the bromide ion. So 3-membered ring formation is also feasible. 3-membered ring formation is also feasible. So this will attack this carbon to form a cyclopropane kind of ring. We all know that this is a Favorsky rearrangement. So in Favorsky rearrangement, so this negative charge push back and this carbon will attack to form a cyclopropane kind of ring. Cyclopropane with the carbonyl compound. Now this OAT minus attack this carbonyl compound, and there are two possible way to break the C bond, this CC bond. So if this CC bond means, if this CC bond break, then we will get this kind of product. This CC bond break means OAT attack carbonyl compound, this bond break, this will be path A, then negative charge will form in this case. This is a secondary carbon containing negative charge. If OAT minus attack the carbonyl compound and this bond just C this bond break, then the negative charge will be in that carbon, that is tertiary carbon, and the COAT group should be in this carbon. Now see these two possible intermediate, anionic intermediate. We all know negative charge on a primary carbon is more stable, negative charge on tertiary carbon is less stable. So negative charge is secondary carbon is more stable than negative charge in a tertiary carbon. So this carbon anion is more stable than this. This carbon ion is more stable than this because the negative charge here is in tertiary carbon, the negative charge here is in secondary carbon. But if this carbon ion is formed, there is no, this carbon ion has no fusor. It will abstract on hydrogen and will convert a neutral molecule. But in this carbon ion, see, in this carbon ion, if this carbon ion push to this negative charge push to this carbon and on bromine is leave, so this carbon ion has some fusor, means this carbon ion can take part in another displacement reactions, that is called intramolecular displacement reaction. So if any intermediate, if in reaction medium there is any intermediate, if it sees that for that intermediate there is chance to take part more reactions, then it will take part that reactions and proceeding forwards. But see, since still this is a, if we consider the stability of carbon ion, this is more stable because this secondary carbon contain negative charge, in this case tertiary carbon contain negative charge. But this carbon ion has a fusor. Fusor means this carbon ion can take part another reaction, that is, if this negative charge push this the negative charge attack this carbon, then this bromine leaves as bromide and double bond form. So that's why I am telling that if there is any intermediate and if that intermediate sees that there is a chance for that intermediate to take part further reactions, so it will proceed by taking part the reactions further. It will not stop at that place. Since this carbon ion has no fusor, this carbon ion cannot take part any further reactions for this intermediate according to structure we see. But in this carbon ion there is chance for intramolecular displacement. So stability of this carbon ion is more than this, but still since this carbon ion has some fusor, so it will take part further reactions to form this kind of product. So then from the then after at the end all the in this case two intermediate will form, but since this product will this intermediate will react further to form this kind of product. Now at last we will get this kind of product. So from this mechanism we can see that if there is any intermediate, that intermediate and for that intermediate there is further chance for taking part in reactions, then it will take part to proceed further. So B intermediate for B intermediate there is possibility for another reaction, so it will take part this intermolecular displacement. So now this will be the product. So for this reaction question number 22, see the product, 5-member ring, methyl adjacent carbon COAT, and that just COAT carbon adjacent to COAT containing a double bond, exocyclic double bond. So 5-member MEET adjacent the double bond containing exocyclic double bond. So adjacent that COT carbon containing exocyclic double bond. So this is the correct options for this kind of product. So this is a Favorsky rearrangement. So up to this Favorsky rearrangement, the anion of Favorsky rearrangement will form in Favorsky rearrangement. Then on hydrogen or H plus, normally H plus has taken by this anion and it will form this kind of product. But up to this Favorsky rearrangement, after that this anion take part in these reactions to displace the bromine as a bromide and form this exocyclic bond. So this is the correct options, and it is a Favorsky rearrangement. So Favorsky kind of rearrangement. Up to this is Favorsky rearrangement. Now Favorsky rearrangement followed by intramolecular displacement of bromide anion. So the correct option is option A. Now move to the next question. So this is the pyridinium. Substituted pyridine has given tertiary butoxide, butanol, and benzaldehyde, then heat. So these are the options. Now see the mechanism. So there are three methyl group. One is connected to nitrogen. One is that two positions of pyridine ring. One is 2, 3, 4, 5 positions, or you can say 1, 2, 3. 3 positions methyl is there. Now among this 1, 2, 3 methyl group, this methyl group hydrogens, or this hydrogen are most acidic among these 3 methyl group, because we will discuss later. Just see the mechanism now. Now base will abstract this proton. It will resonate. This is the resonant structure. Then it will attack the benzaldehyde like this and form OH. Then after heating, this H and OH leaves as water molecule to form double bond. Now consider this molecule. Why this hydrogen has abstract by this base? Why this and this are not take part in this case? See, we all know that the alpha keto, this is a keto group. This is alpha positions. This is the keto methyl. This we can say this is a keto methyl. This should be any R group. So this we can say this is a keto methyl group. So the keto methyl group, the hydrogen is the hydrogen at methyl positions. So in a keto methyl group, the hydrogens for methyl group are acidic. We all know, if this hydrogen is abstracted by base, then the anion stabilized by this carbonyl compound. So on inolate form, so we all know that the hydrogen atom in methyl group of a ketomethyl moieties are acidic. Now since nitrogen and oxygens so are same row, means they are in periodic table, they are close to each other, adjacent positions. So they have around some same electronegativity, not same, but the electron differences are the difference in electronegativity are less for nitrogen and oxygen. So we can compare this ketomethyl group like this. C double bond N and C double bond O behave like same. Since oxygen and nitrogen are placed in periodic table close to each other, so C double bond O and C double bond N behave close to same, not 100% same, but C double bond O and C double bond N behave like same. Since these hydrogens, that is ketomethyl hydrogens, are acidic, we can say these hydrogens, just C double bond N group and connected a methyl group, that hydrogen will be also acidic. So in that case, see, this is a C double bond N, one group is there, that is methyl. That's why likewise a ketomethyl group, this we can compare with a ketomethyl group with the C double bond N CH2H. So this hydrogen will also be as much as acidic as this ketomethyl, not 100% same, but close to 80 or 90% same acidic as ketomethyl carbon. So this is the chemistry of that methyl group. Since oxygen and nitrogen close in periodic table, oxygen and nitrogen are spaced closely, that's why their chemical behavior are somewhat same. That's why in ketomethyl group these hydrogen are acidic. So if there is C double bond N and adjacent position on methyl group is there, that hydrogens will also be acidic. That's why this hydrogen are more acidic than this hydrogen or this hydrogen. So base will abstract this hydrogen and it will take part in resonance via this double bond. Likewise the CO group, then this nitrogen lone pair push back and this carbon attack the benzaldehyde. It will form a bit this is a alpha beta hydroxy imine, or you can see this is C double bond in means imine, this carbonyl it is imine, so beta hydroxy imine. Likewise the beta hydroxy carbonyl compound, now upon heating this H and OH leaves as water to form this kind of product. So see the options. This methyl, the alpha methyl group take part in the reactions. So sorry for a small mistake, that is I forgot to put the pH here. So in every in every options on pH should be there, on phenyl should be there, on phenyl should be there, on phenyl should be there, because we are using benzaldehyde. If we are used acetaldehyde, then it is methyl, it is okay. But since we are using phenyl benzaldehyde, there should be phenyl, means not methyl, phenyl. So I forgot to put the phenyl group there, so for that small mistake, so sorry for that. So the correct option is this phenyl group should be there, so the correct option is D. In this place phenyl should be there. If we are used acetaldehyde, then it's okay, methyl group is okay. So we are using phenyl benzaldehyde, that's why phenyl group should be there. So that is a small mistake, but the main chemistry in this reactions, or in this case, is this ketomethyl with this imine, alpha methyl imine. This ACE and ACE acidity somewhat same. That's why base abstract this hydrogen, not this methyl group or this methyl group. So at the end we will get this product after dehydration. So correct option is D. Just keep in mind that pH should be there, in every option pH should be there. So let's move to the next question. So this is a carbonyl compound. So 1,3-dicarbonyl, we can say that 1, 2, 3, this is the A star, we can say this is a 1,3-dicarbonyl compound. So NaOT ethanol epoxide is there, HBr heat, NaOAT, two products. So the products are, these are the options. Among these four options, two will be the products. So in this case also there will be a major and minor product. So let's see the mechanism. This is the reactants. First NaOT ethanol epoxide, then HBr heat, then NaOT. See, this is a 1,3-dicarbonyl compound. This carbon is more acidic, means this hydrogen of this carbon is more acidic. So base will abstract on hydrogen from this carbon, and this negative charge will take part in resonance with this CO, also this CO. So this is a more stable, extremely stable carbon ion. So these hydrogen are extremely acidic. That's why, because the carbon ion is more stable. Now this carbon ion, this is the inert form. It will attack the epoxide and ring will open. The epoxide ring will open, either this or this, same fashion, same product will obtain, because this is a symmetrical epoxide. Either it will attack this carbon or this carbon, same will be the result. So see, after ring opening, this product will form. In this case also, see, when there is present a internally attached nucleophile. When there is a presence of internally attached nucleophile, and if there is chance for that nucleophile to attack in any positions, any possible positions, it will attack. It will not abstract any hydrogen from ethanol. See, in the reaction mixture ethanol is there, but in presence of abstracting hydrogen from ethanol, it will see this intermediate. This is a nucleophile internally attached with this molecule. It will see that there is a positions which this O minus can be attacked. So it will attack this carbonyl compound via internally to form a cyclic lactone. So now this cyclic lactone is formed. If we use HBr, then this carbonyl compound, this O, become protonated, and this Br minus will attack these positions to release this. Br will attack these positions. Now this bond will break and this charge become neutralized. So see, and now in this place, after heating, decarboxylation take place. So this bond abstract this hydrogen, this bond break, and this bond will also break. We all know the how this is the mechanism for decarboxylations, that is beta so beta carboxylic acids. So beta keto, this is the carboxylic acids alpha beta. So in beta keto carboxylic acid moiety, how the decarboxylation take place, this is the mechanism. This double bond break, it will attack these hydrogens. Now this bond break and this bond will break to form this kind of molecule, and upon releasing of CO2. Now this is the enol form, it will transform to the keto form via tautomerization. Now they use base. So this base can abstract proton from this side and this side. See, since there is no extra carbonyl compound, see, this is the 2 degree carbon ion, this is a 1 degree carbon ion. We all know that 2 degree carbon ion is more less stable than 1 degree carbon ion. In both the carbon ion, carbonyl group is present adjacent. So in this case, both will form. This is more stable 1 degree, this is less stable 2 degree. So both will form, but the major carbon ion form will this primary. Now if this secondary carbon ion will attack this carbon, that is intramolecular, this is also intramolecular substitutions or displacement, it will form a 3-member ring like this. If this primary carbon ion attack this carbon, it will form a 5-member ring. Also see, this is less stable, it will form cyclopropane ring. This is more stable, it is form 5-member ring. So among this 5-member ring, this cyclopentanone is major product. Now see, if in the last step, if we are using base, that's why the more stable carbon ion is formed, the primary, it will attack this bromine containing carbon to form a cyclopentanone. Now if we use a acid, if we treat it with this molecule with the acid, then what will happen? Then these reactions, this reactant react via a more stable enol form. If it react with enol form, then this is the more stable, not the other one. This side, the enol form forming via this side, that will less stable than this enol form. If we use acid instead of base, then this reactant transform into enol form and more stable enol form like this, and this will attack this carbon to form a cyclopropane ring. So if the last step we are using base, then this will be the major product, this will be the major product, this will be the minor product. So but that percentage was not mentioned here. So in basic medium, this compound will give cyclopentanone as a major product, but in acidic medium, if in the last step, see, in the last step we are using any acids. So acids means not strong acids, so weak acids, then it will form a enol, this kind of enol, which is more stable enol, more substituted enol, not the other one. So it will transfer a more stable enol, then this enol react with this bromide containing carbon via intramolecular SN2 substitutions, and it will form cyclopropane ring, this compound. So in acidic medium, this will be the major product. In basic medium, this will be the major product. Yeah, they used HBr in this step, but at last step they use sodium hydroxide. If they use again HBr, that is also acid, then these reactions follow this path via formation of more stable, and this time this will be the major product, not that. Since they used base last step, so this will be the major product via more stable anion to give the cyclopentanone, and this will be the minor product. So the two products of these reactions are, since base is there, so C and D. D is the major since we are using base. C is minor. If in number 3 they also if they use something acidic, acid, that is also HBr, we can use also HBr or any other acids, then we will get this as a major product, because that time the reaction proceed via more stable enol form, not the enolate form. So in this case, option C and D are correct, means these two are the possible products, these are the major, and this is the major and this is the minor. So it is done. Now let's move to the next question. So this is a very interesting question. So see, this is in on molecule, 2 hydroxyl group is there on carbonyl group. We all know that carbonyl group, any carbonyl group react with alcohol to form ketal, ketal in presence of H plus. Now since in this molecule there are 2 hydroxy group attached in the molecule along with a carbonyl compound, so it will internally react in presence of H plus to form a ketal. So to form a ketal. So now which ketal will form? So we will see the, so in this case, since the formations of ketal resulting the formations of 2 6-member ring, so we have to decide that which this is a spiro, we can see spiroketal kind of molecule. This linkage is called spiral linkage. So 2 6-member ring linked via a spiral linkage, so this is called spiroketal. So among these 4 options, which one will be the correct one? So we have to decide the correct conformations of this 2 cyclohexane chair form. So let's decide. 2 alcoholic OH group means 2 hydroxyl group within the molecule along with the carbonyl, so there is obviously chance of formation of ketal moieties. So in this case it is a spiroketal. So let's see the, so this example is given in Claydon. So the if you go to the chapter it is the saturated heterocycle chemistry. So I think there are 3 chapter in the heterocycle chemistry. First on saturated heterocycle, then the reactions, and then aromatic heterocycle. So this example is in the saturated heterocycle part. So after forming ketal, so this is called spiroketal structure. So if R is different, then this compound is a insect pheromone. So just changing the R value means the R is different substituent. This kind of spirochetal is a insect pheromones. So let's see the discussion. So regarding the conformation of the two cyclohexane chair. So this spirochetal, so we all know the anomeric effect in cyclohexane. So if there is a oxygen atom in the ring, 6-member ring, and that oxygen atom in the 6-member ring, and that carbon containing a substituent, which if that adjacent carbon, that is called anomeric carbon, if that anomeric carbon containing a substituent, and in the ring there is a oxygen atom and the anomeric carbon contain a substituent, then if the substituent contain more electronegative, the substituent is more electronegative, then there is more chance for that substituent to rest in a axial positions due to anomeric effect. Normally in simple case, larger the substituent, larger the size of the substituent, it will rest in a equatorial positions. But in this case, due to anomeric effect, this is anomeric carbon, this oxygen atom should be in the ring, then the anomeric effect will observe. See, this is a oxygen atom in the second cyclohexane ring. So we all know in anomeric effect, the transfer of lone pair of electron from the oxygen will transform to the sigma star of the substituent. So consider this is a cyclohexane, and just exclude this red part of that cyclohexane, just consider this green part. This is a OMe kind of substituent. Just consider this is a OMe kind of substituent. We all know in this case anomeric, due to anomeric effect, the substituent containing a electronegative atom will rest in an axial position. More the electronegative, more will be the chance for that substituent to rest in axial position. So in this case, see, there are two lone pair. The green lone pair donate electron density to the sigma star of this CO bond. So that's why it's become stable due to this charge transfer or electron transfer. Now if we consider just consider this is a cyclohexane chair form. This is a cyclohexane chair form. This oxygen atom is in the ring. And now just exclude this broad red this red part. Now just consider the orange O. This is a cyclohexane chair. This is a cyclohexane, and see, this is the axial and this is the equatorial. For this cyclohexane, this is the ring oxygen, and this is the axial substituent, this is the equatorial substituent. For this cyclohexane, this is the axial and this is the equatorial. If we consider this cyclohexane, due to anomeric effect, this lone pair, green lone pair of oxygen, donate the electron density to the sigma star of this CO bond. Now if we consider this cyclohexane chair, then the lone pair, this orange lone pair, donate electron density to the sigma star O of this orange CO bond. So for this cyclohexanes, this is axial CO. For this cyclohexanes, this is axial CO substituent. This is more stable structure because due to anomeric effect, only in this structure, the donation of electron means the lone pair of electron donations or transfer of electron from this lone pair will occur in this sigma star of this CO bond. For this case, the green lone pair donates some electron density to the sigma star of this CO bond. So for this cyclohexane, this green CO is axial. For this cyclohexanes, the orange CO is axial. So this is the most stable conformer of this spirochetal moiety. So since there is involvement of two lone pair and charge transfer of two CO sigma star bond, that's why it is called double anomeric effect. If there is present only one oxygen atom in the ring, only one substituent, then it's called anomeric effect. Since for these cyclohexanes, this is a axial, this is equatorial. For this cyclohexane, this CO axial, this is equatorial. So since there is involvement of two ring oxygens means if we are considering this cyclohexane, then this is ring oxygen. If we are considering this is cyclohexane, this is ring oxygen. This is ring oxygen, then this will be the substituent. We can consider substituent, axial substituent. If this is the ring, means cyclohexane ring, this is ring oxygen, then we can consider this is the axial CO substituent. So this is the most stable conformer of this spirochetal moiety. Here double anomeric effect will observe. I think इस टाइप का क्वेश्चन पहले कभी नहीं पूछा गया कोई भी एग्जाम में, CS है नेट. सो नॉर्मली एनोमेरिक इफेक्ट रिलेटेड क्वेश्चन हमेशा पूछ लेते हैं क्वेश्चन ये नॉर्मली नेट और गेट एग्जाम में. बट दिस टाइप ऑफ डबल एनोमेरिक इफेक्ट क्वेश्चंस, सो इस टाइप का क्वेश्चंस सिलेक्ट होने का चांस बहुत चांस ज़्यादा है नेक्स्ट और अपकमिंग एग्जाम में. सो see these three different conformer, possible three different conformer. This is a cyclohexanes. See, for this cyclohexanes, for this cyclohexane ring, if we are considering, then this is the axial, this is equatorial. So this oxygen is equatorial. If we are considering this cyclohexane, then this is the axial and this one is the equatorial. So we can call equatorial. This electronegative substituent is equatorial for both cases. Now for this cyclohexane, this is the axial. For this cyclohexane, this is the axial substituent. Now it is axial. The substituent, if we consider this is a substituent, then it will axial for this cyclohexane, it will axial for this cyclohexane. Now this, for this cyclohexanes, this CO bond is axial. For this cyclohexanes, this CO bond is equatorial. So this is axial equatorial. Now the most stable conformer of this among these three is this one. So due to double anomeric effect, this stable become more stable. So green lone pair donates electron to the this sigma star CO bond. This lone pair anti to the orange CO sigma star donate the electron to the this sigma star CO bond. That's why due to double anomeric effect, this structure become more stable. So if we see the options, see the among the four options, for this cyclohexanes, see for these cyclohexanes, if these are cyclohexanes, then this CO for this CO bond is axial to these cyclohexanes, and if this is a cyclohexane, then this CO bond is axial and this is equatorial for this cyclohexane. Now for this cyclohexanes, this is axial, this CO, this is equatorial, but for this cyclohexane, if we consider this ring as cyclohexane, then this CO bond is equatorial and this CC bond is axial. So this is not the stable one. For this, just for this cyclohexanes, see, this is equatorial, this is axial. For this cyclohexanes, this is axial, this is equatorial. This is axial, this is equatorial. So this is equatorial kind of structure. For this cyclohexanes, this is equatorial. See, this CO bond equatorial for this cyclohexane, and for this cyclohexanes, this CO bond is also equatorial. So this is also a kind of equatorial attachment. So option 1 is correct, where the substituent O atom means this CO bond is axial with respect to other cyclohexane ring. This CO bond is axial with respect to this cyclohexane ring. This CO bond is axial with respect to this cyclohexane ring. So this is the more stable conformer of the spirochetal molecule. So due to the double anomeric effect. So in this molecule, double anomeric effect will observe. ये क्वेश्चन कुछ कॉन्सेप्चुअल था. सो नॉर्मली इस टाइप का क्वेश्चन नॉर्मली नहीं पूछा गया. नॉर्मली एनोमेरिक इफेक्ट रिलेटेड क्वेश्चन पूछते हैं, बट दिस डबल एनोमेरिक इफेक्ट क्वेश्चन कभी भी पूछ सकते हैं. सो this is a very important questions for upcoming examinations. So any competitive examinations, either it is Csir-Net, GATE or Barc or any MSc entrance, IIT examination. So yeah, this is a very important question. So let's see the next questions. So this is a very important molecule. So these reactions, so this is some steps from the total synthesis of reserpine molecule. So we all know the reserpine as a natural product. So from this these are 3 to 4 steps for the total synthesis of natural products. So in the total synthesis there are more than 20 to 25 steps involved. Among these 25 steps I picked only 4 steps which are important, in which we can learn some use of reagents, use of some stereochemistry. So let's see the mechanism. So this is the whole compound. First diazomethane, then acetic anhydride pyridine, then cadmium osmium tetroxide, then sodium iodide, then H2O methanol, then again CH2N2 means diazomethane ether. So this is H2O, not H20. This is H2. This is just drawing mistake. So this is the drawing mistake. This is H2O, not H20. This is H2O. So let's see the mechanism. Then we will see the stereochemistry of the product. So see, this is the given compound, compound as starting material. Now diazomethane. See, if there is any free carboxylic acid and we are treating that molecule with diazomethane, then this ester will form, carboxyl ester, like this way. First this acid react with diazomethane, diazomethane abstract on hydrogen from this acid, it will become CH3N2 plus, then this is acetate minus attack via SN2 or either SN1, means since N2 plus is a very good leaving group, there is two possible. First this N2 plus leave, then CH3 plus form, then this acetate anion attack this CH3 plus, or either via SN2 mechanism, but maximum possible is SN1 because N2 is the best living group in the world. So there is a term like that N2 is a best living group in the world. So N2 plus leaves easily to form a CH3 plus, means cation, methyl cation, then it will attack this. So maximum possibility is via SN1, not SN2, but both are possible. So in this way, that this CO2 is will form a carboxylate, ester like this. Now in this molecule we are using pyridine acetic anhydride. Since CO2 OMe is there, one free OH is there, so pyridine abstract this hydrogen from this alcoholic OH. Now this O minus attack this acetic anhydride to form OAC. See the stereochemistry. Just we have to concentrate on the each mechanism and using of each reactant. Then automatically we will observe the exact stereochemistry of the product. We don't have to match with the options again and again. But if we carefully do mechanism and concentrate on the proper use of reagent, then automatically we will observe the exact perfect stereochemistry of the product, and then we will automatically gain the answer, correct answer. So let's see the next use of reagent. Now see, there is a double bond. This is an unsaturated carbonyl compound, but double bond is there. If we use osmium tetroxide, then we all know syn hydroxylation from less hindered side will take place. So since this hydrogen in this link, hydrogens are below the plane, and this bond, the 6-member ring, this bond are above the plane. So the upside means double bond, the upside is more hindered. That's why syn hydroxylation occur from the below to the double bond, means the same as the hydrogen stereochemistry. So the syn hydroxylation will occur same as the stereochemistry of the hydrogen attached in the bridge. So we will get syn hydroxylations. Now we are using sodium iodate. So NaIO4, so sodium iodate. So it will, using this reagent, there will be oxidative cleavage. So if there is two OH group adjacent to each other, then NaIO4 or HIO4 cleavage the bond CO. So this bond, if there is adjacent OH group, means 1,2-diol. So this, there is 1,2-diol, this bond will break and it will form a aldehyde. Since this CH2OH and there is a CO bond, not just C, in this case C, in this case only C bond is there, not O. So in this case this bond will not break, oxidative cleavage occur between a bond that bond connected with a oxygen atom. In this case OH is there, 1,2-diol. In this case C double bond O is there. So if we use excess NaIO4, it will cleavage this bond. Now this CH2OH form oxidative cleavage, means cleavage and oxidation. It will oxidize to aldehyde. Now this, after cleavage this bond, this also CH2OH, this part also become aldehyde. Now since there is another double bond CO in that carbon, this bond will also break. Now this CHO further oxidized to formic acid, means HC2OH. First cleavage, oxidations of aldehyde, alcohol to aldehyde, both alcohol to aldehyde. Cleavage first, oxidations, aldehyde. Second cleavage, aldehyde oxidized to acid, and then CO group also transform into acid. So this is the important step. If we are using excess NaIO4, only this 1,2-diol portion will not take part, also this bond will take part. Means first cleavage 1,2-diol, it will become aldehyde, also aldehyde. Second cleavage, this aldehyde become formic acid and it will knock out from this compound. Now this CO, since this bond is also breaking followed by oxidations, it will become carboxylic acids. Now after these reactions we are getting CH2, this hydrogen is below, means this bond is above, CH2 COOH and CH2OH become aldehyde, so CH2 CHO. So so not CH2 CHO, it should be CHO. Sorry for another drawing mistake. So this is CH2OH, means CH2OH after oxidation become CHO, not CH2 CHO. So this will become just CH2, just CHO. So not CH2 CHO, it will become just CHO and above the plane. So so we just see here that by this mechanism, all this mechanism, we are getting at this position above CHO. Since this bond is above the plane, this hydrogen is below the plane, so this CHO become above. In this case, oxidative cleavage means oxidation cleavage followed by oxidation. Cleavage of this bond, this OH become aldehyde, CH2OH become aldehyde. Now again this bond will cleavage, then this aldehyde become formic acid and it will knock out. Now this CO group become carboxylic acids. So we will get CH2 COOH and CHO, and other remain same. So the final product, CO2Me OAC above, middle OMe below, CHO above, CH2 CO2 OMe above. So in the options, sorry for drawing mistake, in the whole options, so this is not this is only, this should be CHO, not CH2CO. That CHO should directly connect to the cyclohexane. So so this so just you people correct in your copies, or so in the options, so CHO above, CO2 OMe above, the other things, see the other things OMe below, that CO2 OMe above, OAC above, adds that as starting material configuration. CO2 OA is above, so CO2 OMe become above, CO2 OH, that OH become above means OAC above, OMe3 below. So since in this step CO2 is formed, in last step CH2N2 again, like first step again carboxylate ester will form, then this CO2 is become carboxylate. First carboxylate, then again carboxylic acid, then again carboxylate ester, carboxylic acid to carboxylate ester, then again carboxylic acid in this step, then again carboxylate ester. So the option should be, one option should be correct, and here this is not CH2CHO, this should be CHO. The CHO bond should be connected to the this cyclohexane ring. So please you people correct this during drawing in your copies, please correct, and please sorry for that, for drawing mistakes. ये हो जाता है कभी कभी, सो ड्राइंग मिस्टेक प्लीज सॉरी फॉर दैट, बट आप लोग जब कॉपी में ड्रॉ करेंगे सो प्लीज मेंशन एंड प्लीज कीप इन माइंड दैट ड्रॉ करने का टाइम नॉट CH2CHO, दिस शुड बी दिस इज CHO, दिस ऑल्सो CHO, not CH2. This CH2 group will not be there, this CH2 group should not be there, so only CHO. See the mechanism in this case, see, after breaking this bond, this CH2OH become CHO, just CH2OH become CHO, and also CHO after again oxidation become formic acid, and this will become carboxylic acid. Then after reaction with diazomethane, it will transform into carboxylate ester. But this is CH2OH, so this become only CHO, not CH2CHO. So that is a drawing mistake. So the correct answer is option A. Again I am telling you, that's please when you people will draw in your copy, so please make sure that this should be CHO, not CH2CHO. So I hope discussing these 6 questions, yeah, obviously it took 1 hour, but I think it is a long time, but I think हम लोगों ने कुछ नया सीखने को मिला, कुछ नया टाइप का रिएक्शंस, नया टाइप रिएक्शंस बस इस तरह का क्वेश्चन नॉर्मली पूछते हैं वो कॉम्पिटिटिव एग्जाम में, सो इस तरह का ही क्वेश्चन नॉर्मली सिलेक्ट होता है क्वेश्चन में, सो हम लोग वो सोच के ऐसा क्वेश्चन सिलेक्ट किया, मीन्स so we maintain the quality of the questions. So by this by the discussion of these 6 questions, I think will help you a lot for upcoming examinations, to improve your knowledge in organic chemistry, and to solve the new questions, it will help to solve the new questions. So I think it will help you a lot. So yeah, that's all for today. Thank you for watching, and thank you for your support. So if this video will be helpful for you, please share and subscribe. So again I am telling you this, during the discussions, mechanism drawing or anything, if you have any doubt regarding any questions, so I am frankly and honestly telling you that अगर किसी क्वेश्चन में भी कुछ आप लोगों को कुछ प्रॉब्लम लग रहा है, जो इसमें थोड़ा शायद ठीक नहीं है, प्लीज आप लोग कमेंट करके बताइएगा. सो प्लीज कमेंट इन द कमेंट बॉक्स दैट्स आप लोग का कुछ डाउट है इसमें, तो इसमें ये मैंने ठीक नहीं किया, ऐसा आप लोग कमेंट करके बोल सकते हैं, नो प्रॉब्लम. सो गलती हो सकता है, गलती तो हो ही जाता है. सो या आई एडमिट दैट गलती हो जाता है. सो प्लीज if you have any doubt regarding any questions, if you think that that is not a actual mechanism, there is possible of another mechanism, that is there is another explanations, please comment in the comment box. So thank you for watching again, and stay tuned. We will see lots of questions from different part of chemistry, so that will boost your chemical knowledge. So bye, stay safe, stay healthy.